So we continue with the light energy, and now we are going to discuss what is laws of refraction. Now these laws of refraction are also called as Snell's law. Okay. So refraction of light obeys the following two laws, also known as Snell's laws of refraction. So what are the two laws we are talking about? First one, the incident ray, the normal at the point of incidence, and the refracted ray all lie in the same plane. And there is a reason I am able to draw them like this. You can see that this is the incident ray, this is the refracted ray, this is the normal. All of them could be easily drawn on the page, on the board. That's why they all lie in the same plane. So the first thing is that incident ray, refracted ray, and normal lie on the same plane. That's the first law. Okay, the incident ray, the normal and the point, normal at the point of incidence, and the refracted ray all lie in the same plane. Second one, very important. For a given pair of media and a given color of light, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is always constant. That is, that R constant is equals to sine I upon sine R. Okay. Now, so what does it mean? For air to glass, okay, when I am taking any glass of a particular optical density and normally air, तो जितना refraction इसका होना है, the sine is particularly a mathematical term called as a trigonometric ratio. Okay, there is a trigonometric ratio which you will be learning in the 9th standard. So right now you just know it that it's a kind of a ratio. So that is sine. Sine is, full form is sine, S-I-N-E, which is in a short form we write it as sine. So it is sine, which short form is S-I-N, sin. Okay, so sine of angle of incidence upon, so that is the value of the angle of incidence upon the value of sine of the angle of refraction. उन दोनों का ratio is always constant for a given pair of media or given color. See, light is not just one color. Light is made up of 7 colors. You know that, Vibgyor. Okay, violet, indigo, blue, green, yellow, orange, red. So here you can see that for a given pair of medium, that is air glass, air water, glass water, वैसा कोई भी medium रहेगा, तो वो medium में, in any medium, any two medium we are talking about, the ratio of the sine of angle of I incidence and the angle of refraction is going to remain constant. So this is the second law of the refraction. So what is the second law? That for a given pair of media and given color of light, the ratio of the sine of the angle of incidence I to the sine of the angle of incidence to the sine of angle of refraction R is constant. That is, sine I upon sine R is equal to constant. This constant is denoted by the symbol mu. So this constant is given by the symbol mu. Okay, mu is a Greek letter and that is written as M-E-W, but actually it is just a U. It's just like this. It's just a U. It's mu. Okay. Now mu is called as refractive index. Okay, so refractive index is nothing but the mu, that is the ratio of the sine of angle of incidence to the angle of refraction. So it is known as the constant is denoted by the symbol mu. It is known as the refractive index of the second medium with respect to the first medium. It is given as mu is equals to speed of light in first medium upon speed of light in second medium. So we can also say that mu over here, when you talk about the mu, so mu is not only sin I upon sin r, but also mu is equals to speed of light in one medium upon speed of light in second medium. Okay, so speed of light in first medium upon speed of light in second medium, that is also given as the refractive index. For example, if the ray of light travels from air to water, then the constant mu is sin I upon sin r is the refractive index of water with respect to air, and is given as mu is equal to sin I upon sin r is equal to speed of light in 1 medium upon speed of. So what is the speed of light in? We know the speed of light in case of air is 3 into 10 raised to 8 upon speed of light in, let's say, water. We had taken it as 2 into 2.25, so it is 2.25 into 10 raised to 8. तो ये कैंसिल हो जाएगा, तो 3 upon 3.25, it is nothing but 4 upon 3. Okay, right? When you divide this thing, it is going to give you as 4 upon 3 or is equals to 1.33. So the refractive index of glass with respect to air is 1.33. Similarly, if the ray of light is traveling from air to glass, so water, refractive of water is 1.33, and when it is from air to glass, it is going to be 1.5. So that is the refractive index will be 3 into 10 to 8 upon 2 into 10 to 8. That is 3 upon 2, which is nothing but 1.5. So that's why the refractive index of glass is 1.5. Refractive index of water with respect to air is 1.33. Note, the refractive index of air is 1, because अगर 3.3 into 10 to 8 upon 3 to 10 to 8 upon क्या रहेगा? It will be 1. So the refractive index of air is 1. No medium can have a refractive index less than 1. Why is that so? Because there is no medium which would have a speed of light greater than that of speed of light in vacuum or air. So because the speed of light is maximum in case of air or vacuum, that's why the refractive index is always going to be a number which is greater than 1. Refractive index can never be less than 1, because the maximum speed what a light can achieve is in air or vacuum, which is 3 into 10 to 8 meter per second. Now what are the effects of refraction? So let's see one by one what are the effects of refraction. First is, the depth of the water in a vessel when seen from air appears to be less. So this is quite simple, that if I have got this particular container, and this container has got water up to this level, you will find that when you try to see something, so now this particular point over here is going to give away a light over here, which is going to travel to your eye. Suppose your eye is over here, this is your eye. So it cannot travel. See, because over here, what is going to happen at the surface? There will be refraction. It is traveling from denser. Now this is the normal over here. So you know that it is traveling from denser to rarer, hence it will going to go away from the normal. So instead of going like this, it is going to go like this, away from the normal. But when you see it, अपना आँख थोड़ी ऐसे करके नीचे जाने वाला है. Okay, our eyes are not going to go like this to like this. So what is going to happen? You will feel as if this particular point is somewhere over here. So this place, this is A, will be seen as A dash. Accordingly, the depth of the water, which is actually this much, will be seen only as this much. This is precisely what happens when you are seeing, standing in front of a swimming pool and trying to enter into the swimming pool. You feel from the top that it is very shallow. But when you jump in, you come to know it was deep enough. Why was that? Because when you jumped inside, at that time, when you are seeing, what you are seeing from the top is the level which is somewhere here. But actually the level is here. Got it? So that's why when you are seeing the depth of a vessel or something, even if you take a bucket also, fill it with water, you will find that the base of the bucket will look raised. Okay? So that is also because of the same principle. So consider a vessel containing water as shown in the figure 5.6. Its real depth is OA, but when it is seen obliquely, that is at an angle O from air, its depth appears to be AI. Okay, instead of AO, this is AO, it will go to be AI. Okay, that's what they have given us, which is less than AO. The reason is the ray of light OA from the point O at the bottom of the vessel is incident normally to the water air surface XY. It travels straight along AD in air. Another ray OB incident from water on the surface XY when passes through air bends away from the normal BN and goes to the path BC. The two reflected rays AO and BC when produced backwards meet at point I. So that's what they are saying, that if I draw a perpendicular like this, so this is one ray of light which is passing over here. This is another ray of light which is passing like this, going like this and then bending like this. So this one is bending like this. When you produce this backwards, so when you produce this line backwards, it is meeting over here at point I. Okay. So this point O. So what happens? The thing which was supposed to be OA is actually OI. Okay. Or maybe we can take this as A and this as O. So OA and OAI. Okay. Thus, for the observer in the air, the depth of the vessel appears to be at AI instead of AO due to the refraction of light from water to air. The apparent depth AI is less than the real depth AO. So apparent depth, this is called as the, so this distance AI is called as the apparent depth. Apparent depth means जो हम लोग को दिखता है, हम लोग को फील होता है, पर actually है नहीं. Real depth is the actual depth. Okay, apparent depth is something which we feel that it is like that, but actually it is not that way. It is the apparent one or virtual one. Now, real depth of apparent depth is equal to refractive index. Since refractive index of water is 4/3, so the apparent depth is 3/4 of the real depth. So we also can see over here there is one more kind of formula, that is mu is equals to, mu is nothing but the refractive index is given as real depth upon apparent depth. Okay. So if I know that from air to water, the refractive index of air to water is 4/3, तो उसका मतलब real depth कितना रहेगा? R upon apparent depth, what it's A. So I can know that real depth is equals to 4/3 times apparent depth, or apparent depth is equals to 3/4 times the real depth. Okay, so 3/4 of the real depth is the apparent depth. That is what you feel when you are standing in front of a object which is placed in water. The change in the depth due to the refraction can be demonstrated by the following activity. Take a coin and an empty glass vessel. Place the coin in the vessel, put the vessel on the table and step back till the coin is just out of your view. It is hidden from the eye by the edge of the vessel as shown. So what exactly you are doing is that you are taking a vessel. This is a vessel. Suppose this is a vessel. Now I place the coin over here, and ये vessel का बाहर का outer wall है. Now when I am seeing it over here, I can see the coin. I can see the coin which is placed over here. So what I do is that I just slide it towards inside, a bit inside, so that I cannot see the coin. The coin should be hidden behind this particular wall. Okay, just behind. ये मुझे दिख रहा तो थोड़ा मैं अंदर ले लूँगा कि it is just behind that thing. And then I pour water into it. When I pour water into it, you will find that, of course, the coin is not going to float, but still you will be able to see the coin. Why? Because the apparent depth of that particular coin has been formed. So what is forming is that the image of that particular thing is seen raised, and hence you are able to see the coin. So that's what they have given you in figure 5.7. So keep your eye in a position and ask your friend to pour water gradually in the vessel. You will find that when there is a sufficient water in the vessel, the coin becomes visible, because then it appears to be slightly raised from the position A to position B as shown in the figure. Explanation: when there is no water in the vessel, the coin is not visible because the ray of light from the coin traveling in a straight line does not reach the eye because it is blocked by the walls of that particular vessel. Okay. In figure 5.7b, when water is poured in the vessel, the coin becomes visible because the ray of light from the point A of the coin traveling in the straight line changes the direction and it bends at the surface of the water and reaches the eye. Thus, the light ray bends as it leaves water and enters air. The ray now appears to come from point B and instead of A. In other words, the coin appears to be raised from position A to position B. So that was the activity 1. We also see the activity 2 now. Take an empty glass beaker and pencil. Place the pencil ABC obliquely in the beaker and look it from the side. It appears straight as shown in the figure 5.8. This is exactly what I showed you in my previous video about refraction. Or maybe it was in the same one, I don't know. I don't remember. Yeah, in the previous one. Now pour water in the beaker of up to its brim. You will notice that now the pencil appears to bend at ABD now and at the surface of the water as shown in figure 5.8b. Explanation: the ray of light coming from the tip C of the pencil bends at the surface of the water as it enters into air, and it appears to be coming from point D. In other words, it is due to refraction of the light from water to air that the pencil ABC appears to be as ABD. Okay, so instead of appearing like this, it is going to bend. Okay, ये ऐसे सीधा जाने के बदले ऐसा bend हो जाता है, तो ये raise हो गया, ये C इधर था, उसके बदले D पे आ गया. So I can see the pencil in a bent form. From the above two things, we conclude that when a light ray passes from one transparent medium to another, it bends. The direction in which light bends depends upon whether the light travels from a rarer medium to denser medium or from a denser medium to a rarer medium. We know that because depending on that, whether it is going to go away from the normal or towards the normal is going to be determined whether the light ray is traveling from denser to rarer or rarer to denser. If it is from rarer to denser, it will go towards the normal. When it is from denser to rarer, it is going to go away from the normal. Now, we'll see certain very important examples what are going to happen in our day-to-day life, which are using the principle of the refraction for us. So, the refraction is seen in our day-to-day life in some cases. Like, for example, early sunrise and late sunset. Okay, a person, even if the sunset has already taken place, the person can see the sun for some few minutes even after the sun has already set. Actually, it has already gone below the horizon. The sun has already gone below the horizon, but still you can see it. Okay, that is, similarly, even if the sun has not reached the horizon, we can see it during sunrise. So it is this way that suppose this is the earth, you are standing over here, and accordingly you have got this as the horizon. Okay, this is the horizon. Now the sun is over here, and this is the layer of the atmosphere around us. So what happens? The ray of light is going to come here from the sun. It is going to come here, and as it is going to reach inside the atmosphere, now we know that it is going to go from vacuum to air. That is, it is going from rarer to denser. So when it is going from rarer to denser, so instead of going in a straight line like this, it is going to bend. Okay, it is going to bend over here, and it is going to go. What happens? It is from rarer to denser towards a normal, and that's why this is going to go towards it. This is the normal over here. So this is going to go towards a normal, and hence the sun, even if it is below the horizon, the person standing over here can see it before or the sunrise or even after the sunset. So that's why, so actually what happens is that the person is going to see it somewhere here. He is going to see that somewhere here. Okay, this is what actually the person is going to see when he is apparent position जो है वो वहाँ पे रहेगा, actual position यहाँ पे है, but because of the refraction of light, because what is going to happen is good like this, bend over here, and will be seen in this particular manner. So before sunrise and after sunset, the upper atmospheric layer are warmer than the layers near the Earth's surface. So the atmospheric layer near the Earth's surface are denser and those above than those above. When the sun is just below the horizon, the light of the sun, while coming towards the Earth, suffers refraction from the rarer to the denser medium, and so it bends towards the normal at each refraction. Due to the continuous bending of the light ray at different successive layers, the sun can be seen even when its actual position is just below the horizon, as shown in figure 5.9. As a result, sun is seen in advance a few minutes before it rises above the horizon in the morning. Similarly, in the evening, sun is seen delayed by 3 to 4 minutes longer above the horizon after the sun sets. So, yeah, what I have shown over here is just a single refraction, considering that there is only, but normally in the Earth, the density of the air is going to be more towards the Earth, and as it goes above and above, the density will keep on decreasing. So that's why there will be layers over here, and accordingly to that layers, this thing is going to be seen over here, because बहुत सारा refraction होगा, bending होते जाएगा, तो bending होते finally what will happen that you will see this thing just above the horizon, even if it is not past the horizon area. So that is the first part. The second thing is mirage in a desert. Now, mirage is a very peculiar kind of a phenomena which can be seen not only in case of deserts, but it is also seen in a very hot sunny day in a very lonely open road. So if many of you must have traveled in the summer season by car or long distance, so when you are going for a long distance in a car, and when there is an open area, you know, if there is something like a highway is there, when the highway is very smooth and it is seen throughout, अरे बहुत लंबा distance दिख रहा है, तो at distant places you will find a kind of a watery area, means it is saying like reflecting area is there. So that particular reflected area which is there is nothing but the mirage. So mirage is something which is going to be basically a one which is going to be called as a reflecting surface due to refraction. Okay, we'll try to understand this thing. Now, sometimes in deserts, an inverted image of a tree is seen which gives a false impression of water under a tree. Now, see, normally क्या होता है, अगर पानी है और tree है, तो automatically the tree का inverted image will be seen in the water. So that वो क्यों दिख रहा है? Because water acts as a mirror. So automatically the tree इधर है, तो उसका inverted image यहाँ पे दिखेगा. But there many times in deserts you will find that same thing over there, but there is no water over there. Okay, there is no water, but still you find that the tree gives you an inverted image downwards. The cause of the mirage is refraction of the light. In a desert, the sand becomes very hot during daytime and it rapidly heats the layers of the air in contact with it. Therefore, the layers of the air near the ground are warmer and hence rarer than the upper layers. In other words, the successive upper layers are denser than those below them. So we are taking an example over here wherein in a hot sunny day, because of too much of sun, the ground has got heated up very fast. And when the ground becomes heated up very fast, so what happens? The area, that is the air above the particular air, about that is going to get less denser, it is going to become like a rarer medium, and then as it goes up it becomes denser and denser and denser. So basically what happened, the area which is around the surface is rarer and the one which is above the surface at the heights will be denser. When a ray of light from the sun after reflection from the top of the tree travels from the denser to the rarer medium, it bends away from the normal. As a result, in refraction at the surface of the separation of successive layers, each time the angle of refraction increases and the angle of incidence of ray going from the denser medium to rarer medium also increases till a stage is reached when the angle of refraction becomes 90 degrees. So let's understand this one. You have got this over here, which is, now let's consider this is water and this is air, and you have know that the ray of light is going to come like this. Okay, this is water में से ये light जा रहा है. So we know that it is from denser medium to rarer medium, so it is going to go away from the normal. So instead of going like this, it is going to go like this. Now what happens if this angle is going to be increased further? So if I increase this angle further, like if I make it like this, what will happen? This thing is going to go much way over here like this. Instead of going like this, it is going to go like this. And a stage will come when this ray of light will have a reflection, or the incident ray ka refracted ray will be on the surface of that particular light. Okay. Ye incident ray ka, see what has happened over here, it is going to go away from the normal. तो पहले जो ऐसे जा रहा था धीरे धीरे धीरे, क्योंकि ये इंक्रीज होते जाएगा तो ये एंगल away from the normal चलते जाएगा, and it will reach a point where it is the maximum kind of a deviation possible, and that is the 90 degree angle. जब 90 degree angle होगा तो क्या होगा, ये जो light है it is now traveling on the surface of the road. So that means what has happened, the ray of light is now, the sun rays which are coming from the sun से जो आ रहे हैं, they are coming over here, they are passing from a denser medium to rarer medium, because the rarer medium is the one which is around the hot sand and the denser medium is above it. So it is going to travel from denser medium to rarer medium, and due to this there will be refraction in such a way that the refraction is going to be producing the reflected ray which will be exactly on the surface of the ground. जब ऐसा होगा तो ये surface of the ground पे जो मिरे ऐसा light का जो effect आएगा, that is nothing but the mirage. So that's why there is a reflection. So you can see when the ray of light from the sun after reflection from the top of a tree travels from the denser medium to rarer medium, it bends away from the normal. As a result, in reflection at the surface of the separation of successive layers, each time the angle of refraction increases, the angle of incidence of the ray going from denser medium to rarer medium also increases till a stage is reached when the angle of refraction becomes 90 degrees. On further increase in the angle of incidence, the ray of light traveling from the denser medium to rarer medium is not reflected but it suffers reflection. So further if I increase this, it is not going to reflect over here, it is going to become reflected. So here it is going to be, ये जो line जाएगा, ये जो angle form होगा, वही angle में इधर form होगा, that is reflection is going to take place instead of refraction, and this is called as total internal reflection. Okay, this is called as total internal reflection. So this reflected ray now travels from the rarer medium to denser medium, so it bends towards the normal at each refraction. On reaching the eye of the observer, an inverted image of the tree is seen. Thus, it gives a false impression of a pool of water in front of the tree. Okay, so in this way, जो image tree से आया था, so exactly what is happening is, let's consider कि क्या हुआ है. We are having this particular tree over here. Sun rays are come over here. It is getting reflected. वो reflection होने के बाद में यहाँ पे this is the denser medium and this is the rarer medium. This is the denser and this is the rarer medium. So the ray of light is coming like this. And when it comes like this, instead of giving, so पहले क्या यहाँ तक refraction हो रहा था, पर अभी क्या हो गया? It is getting reflected back. And when it reflected back, this comes out as the image. The image of this is formed over here. Okay? क्योंकि ये रिफ्लेक्शन हुआ ना, तो हम लोग जब भी हम लोग देख रहे हैं यहाँ इसको, जब भी देख रहे हैं तो क्या हो रहा है? हम लोग जब भी देख रहे हैं तो हम लोग को क्या दिख रहा है कि ये लाइट जो है कहाँ से आ रही है? यहाँ से आ रही है. You cannot see it from here. You feel as if it is coming from here. Right? When you see inside the mirror, do you feel that okay? कोई यहाँ पे है वो मुझे मिरर में दिख रहा है? नहीं, मुझे क्या दिखता है? कोई वहाँ पे है जो मुझे यहाँ पे दिख रहा है. See, suppose I'm standing in front of a mirror. Okay, there are three people standing in front of a mirror. The first person can see the third person can see the first person. But do they see them direct? But हम लोग के mirror में क्या दिखता है? As if he is just standing in front of me. Similarly over here, the tree is here. It is here, but this person feels as if he is standing in front of him like this. So this reflection, what is seen, is nothing but the mirage. So on reaching the eye of the observer, an inverted image of the tree is seen. Thus, it gives a false impression of the pool of the water in front of the tree. This is nothing but mirage. Understood? So this was what happens due to refraction. And we now see the refraction in the case of rectangular block in the next video.